Story 1. Today we start with a practical workflow for developers. Git commands I run before reading any code. The author argues that before opening a single file in a new codebase, you should run specific Git commands to analyze the commit history, which reveals who built the project, where problems cluster, and whether the team is shipping confidently or tiptoeing around landmines. By identifying the 20 most changed files from the last year, you can spot high churn on files nobody wants to own, which is a clear signal of codebase drag, where every change requires patching a patch. The community reaction highlights practical tools for this, with one commenter sharing verbose jujutsu commands to find the most changed files, authors, and bug clusters. Another user provided a comprehensive list of Git aliases to quickly identify churn and recent bug fixes, while a third joked that most corporate commit messages are just change stuff, suggesting AI-generated messages as a potential solution. With better visibility into your codebase, you can finally start reading the code with confidence. Story 2. Next up is a legendary piece of reverse engineering. I ported Mac OS X to the Nintendo Wii. This project successfully runs Mac OS X 10 Cheetah natively on the Wii, joining a short list of other operating systems like Linux and Windows NT that have been ported to the console. The developer navigated countless unknown unknowns, including bootloader development, kernel patching, and writing custom framebuffer drivers to get the GUI running on the PowerPC hardware. Community members are blown away by the technical achievement, with one praising it as a beautiful PowerPC Unix workstation, while another lauded the write-up for highlighting the surprising robustness of the I/O kit abstraction layers. The post also sparked a nostalgic thread about other successful Wii hacks, from hosting blogs to running Windows, proving the console's enduring potential as a computer. If the Wii can run a 2001 operating system, what else can we unlock from our old hardware? Story 3. In security news, we have Little Snitch for Linux, a tool that brings network visibility and control to the open source world. Just as Little Snitch is a staple on macOS for monitoring and blocking network connections, this new Linux version makes it easy to see exactly which applications are talking to which servers and block the ones you didn't invite. The interface is accessible via a terminal command or a local web UI, offering a progressive web app experience that tracks data volumes and traffic history for any Chromium or Firefox browser. Users are debating the viability of paid tools on Linux, with some wondering if the free version was a strategic move to build a user base in a market where paid software is rare. There are also technical questions about how these firewalls handle requests made by allowed programs, such as a script invoking a browser to upload a file, which adds a layer of complexity to network security. Now that you can see what your apps are doing, you can finally lock down your network traffic. Story 4. Taking a break from the code, we look at a classic piece of sci-fi. They're Made Out of Meat, 1991. This short story by Terry Bisson features a dialogue between aliens who have discovered humanity and are baffled by the fact that our technology and intelligence are produced by biological, carbon-based organisms. The aliens struggle to comprehend that meat can make machines, concluding that humans are the only sentient race in the sector, despite being born and dying as meat. The community reaction celebrates the story's enduring impact, with one commenter noting its connection to another favorite, Bears Discover Fire, and another pointing out how the story mirrors our own inability to comprehend the great silence in the universe. A user also shared a fan-made short film adaptation that brings this bizarre concept to life visually. It's a reminder that sometimes the most profound truths are the ones that seem the most ridiculous. Story 5. The conversation shifts to the future of technology, with ML promises to be profoundly weird. This long-form article explores the author's journey from dreaming of intelligent machines in the 80s to feeling disheartened by the current state of large language models and the ethical implications of their rapid scaling. The piece questions whether the current trajectory of throwing more compute and data at models will lead to true human-equivalent capabilities, or if we are hitting diminishing returns. Readers are divided, with one drawing a parallel to the Industrial Revolution, arguing that we are in a Dickensian era where digital resources are being depleted by rapacious AI companies without clear legal frameworks. Another commenter pushes back, asserting that modern architectures like mixture of experts and sparse attention are far more sophisticated than just throwing more parameters at the problem. As we push the boundaries of what machines can do, we must ask if our societal structures are ready for the consequences. Story 6. We turn to a deep investigative piece titled, Who is Satoshi Nakamoto? My Quest to Unmask Bitcoin's Creator. The article follows the author's journey to identify the anonymous creator of Bitcoin, a quest that involves analyzing statistical patterns, eliminating suspects like Nick Szabo, and staking a reputation on circumstantial evidence. The community debate focuses on the ethics and safety of publishing such a claim, with one user questioning how the author and the NYT cope with the massive target on Satoshi's back, given the billions of dollars in associated wallets. Another reader finds the elimination of other candidates compelling, noting that the story's value lies as much in the rigorous journalistic process as in the potential revelation. The discussion also touches on the shifting perceptions of PGP encryption and the technical debates surrounding Bitcoin's core development. Unmasking the creator might solve a mystery, but it could also create a whole new set of problems for the person involved. Story 7. For the math enthusiasts, we have understanding the Kalman filter with a simple radar example. This tutorial breaks down the Kalman filter algorithm, which is essential for estimating and predicting system states in the presence of uncertainty, such as measurement noise or external factors. The author uses a radar tracking problem to build intuition, showing how the filter combines noisy measurements with a motion model to produce a stable estimate of a moving object's trajectory. The community response is enthusiastic, with the author seeking feedback on clarity and other users offering their own intuitive explanations based on weighted least squares and Bayesian MMSE. One commenter even highlighted a real-world application of Kalman filters in browser-based audio synchronization, proving the algorithm's versatility beyond just robotics or navigation. With a better grasp of these estimation techniques, you can build more robust systems for tracking and control. Story 8. In the AI race, Meta introduces Muse Spark, scaling towards personal superintelligence. This new model is described as a natively multimodal reasoning system with support for tool use, visual chain of thought, and multi-agent orchestration, marking a ground-up overhaul of Meta's AI efforts. The model is available via the Meta AI app and web, with a private API preview opening for select users as part of a broader scaling strategy that includes new infrastructure like the Hyperion data center. Opinions on the launch are mixed, with some users impressed by the model's competitive performance and the strategic benefit of not relying on external APIs for Meta's own products. Others are critical of the user experience, noting a dark pattern that forces a login or account creation before letting users even try the tool, a move that contrasts poorly with competitors. As AI capabilities scale, the user experience must evolve to match the power under the hood. Story 9. On the policy front, John Deere to pay $99 in right to repair settlement. Farmers have long fought against the agricultural giant for the right to repair their own equipment, culminating in a landmark settlement where John Deere agrees to pay $99 million into a fund for those who paid for authorized repairs since 2018. The settlement also includes a commitment to provide the digital tools required for maintenance and diagnosis for 10 years, addressing a core complaint about lockdown firmware. Community members share anecdotes about switching to competitors like Kubota or Massey Ferguson due to poor servicing and the aggressive American-made rhetoric from John Deere owners, which often mask their own equipment failures. The discussion also highlights how the 2022 firmware cracking by SIC codes likely pressured the company into compliance with GPL obligations. This settlement marks a significant victory for the right to repair movement in the agricultural sector. Story 10. For the hardware hackers, there is a guide on USB for software developers, an introduction to writing user space USB drivers. The article demystifies the process of writing drivers for USB devices, arguing that it is no more difficult than writing a network application using sockets, despite the common misconception that it requires complex kernel code. The post serves as a high-level introduction for developers who may not have a background in embedded systems, but want to interact with USB hardware directly in user space. Readers are finding this timing crucial, with one user planning to use the guide to create a user space driver for a MOTU MIDI interface that currently lacks support on Linux or OpenBSD. Others contribute by sharing libraries written in Go to avoid C dependencies and noting limitations on newer macOS systems, where security features restrict overriding system drivers. With the right tools, you can bring custom hardware to life without touching the kernel. Story 11. Finally, we look at a breakthrough in model training, Megatrain, full precision training of 100B plus parameter LLMs on a single GPU. This paper introduces a framework that allows training massive language models by storing parameters and optimizer states in host memory while using GPUs as transient compute engines. The approach minimizes persistent device state by streaming parameters in and out for each layer, effectively bypassing the VRAM limitations that usually prevent training large models on consumer hardware. The community reaction is a mix of excitement and pragmatism, with some users excited to train larger models locally on their home RTX 3080s, while others point out that the training speeds are still quite slow compared to multi-GPU setups. Critics also note that there are other optimization tricks, like using different optimizers or quantization, that could further improve performance. This technique could democratize access to large-scale model training for researchers and hobbyists with limited resources.